Assalamu alaikum wa rahmatullah. Our lesson today, we will solve the revision sheet number 1 about lessons mass, weight, linear momentum, and centripetal force. The first question is, in the opposite figure, velocity of E equal more than or less than velocity of B. To solve this problem, first from the graph, we have a relation between mass and linear momentum. Mass on y-axis and linear momentum on x-axis for body A and body B. Okay? Firstly, we must know that for any graph, you must know what is the physical quantity determined from the slope. The relation between mass and linear momentum is linear momentum equal mass by velocity. So, to find the physical quantity determined from the slope, mass over linear momentum, mass over linear momentum equal 1 over velocity. So, slope equal 1 over velocity. Then the body which have high slope, its velocity will be smaller than the other body. Okay? So, from the graph, if we draw from the intersection point of line A and B, if we draw line parallel to x-axis, the line A makes angle more than line B. That means slope of A more than slope of B. Since slope of A more than slope of B, that means velocity of A is less than velocity of B, because the slope have an inverse relation with velocity. Velocity of A less than velocity of B. Question number 2. If the force acting on two masses, as in figure, this force equal 18 Newton, as shown in figure, then the acting force of mass 4 kg, 18, 12, 6 or 3 Newton. The force 18 Newton acting on the two masses. That means we can get the common acceleration between the two masses. The common acceleration equal total force over total mass equal resultant force عندنا equal 18 Newton and the total mass equal 6 kilogram. So the common acceleration will be equal 18 over 6 equal 3 meter per second squared. Okay? Then the force acting on mass 4 kilogram equal mass times acceleration, which equal mass 4 kilogram times acceleration 3. The result is 12 Newton. So the correct answer is number B. Number 3. A force of 20 Newton acting on body of mass 10 kg at rest to move by uniform acceleration, then its linear momentum after 4 seconds equal. To get the linear momentum after 4 seconds, we must know what is the velocity of the body after 4 seconds. So we want to determine the value of the final velocity after 4 seconds. Okay? The given force 20 Newton acting on body of mass 10 kg. That means we can get the acceleration of the motion. Acceleration equal force over mass. Force equal 20 Newton. Mass equal 10 kg. So the result of the acceleration 2 meter per second squared. Okay? Body start motion from rest. That means VI equals 0. We want to get the value of final velocity after 4 seconds. time equal 4 seconds. From first equation of motion, we know that final velocity equal v initial plus a times t. That means final velocity equal v initial 0, acceleration equal 2, and time equal 4. So the final velocity equal 8 meter per second. Okay? This is the value of final velocity after 4 seconds. That means the momentum of the body, which equal mass by velocity. Momentum equal mass of body equal 10 kilogram. And final velocity after 4 seconds equal 8 meter per second. So the result will be equal 80 kilogram meter per second. Don't forget the unit. Number 4. Body moves in a circular path by constant speed if the radius of the path increased 4 times its value and its speed increased to double its value, then the centripetal force acting on the body. We want the change of velocity and the change of radius. What is their effect on force? Since relation between the centripetal force and velocity and radius equal mv squared over r. That means F is directly proportional with square of velocity and inversely with the radius. Okay? The easy way, or the simplest way to find what's the change of the force, we will substitute for the change of velocity and the change of radius. Force directly with v squared over r. That means velocity increased to double its value. Velocity increased to double its value. Okay? That means we substitute by the velocity 2 and we have power 2 from the rule. And the radius is increased 4 times. So we substitute for the radius equal 4. That means the result equal 1. That means the force will be equal 1 multiplied by its original value. That means the force is constant. The force remains constant. So the solution is number C. Number 5. A rocket goes from rest to 9.6 km per second in 8 minutes if the rocket mass equal 8 times 10 power 6 kilogram. And in this problem, assuming at constant acceleration, what is the net force acting on the rocket? Okay. Firstly, the velocity of the rocket equal 9.6 kilometer per second after 8 minutes. Okay. The rocket starts from rest. That means Vi equals 0. Final velocity after 8 minutes. Time 8 minutes, that means 8 times 60 equal 480 seconds. Okay, the speed equal 9.6 kilometer per second. Okay, final velocity equal 9.6 kilometer per second. Okay, we must convert kilometer to meter. Kilometer must be converted to meter. Equal 9.6 multiplied by 1000 kilometer to meter. From kilometer to meter, we multiplied by 10 power 3 to convert it to meter. Okay, 9.6 times 1000 or 10 power 3 equal 9600 meter per second. That's the final velocity. Okay, we want to get the force. To get the force acting on the rocket, that means we must have the acceleration. We can find the acceleration from the relation of first equation of motion, V final minus V initial over time. V final equal 9600 minus V initial 0 over time equal 480. so we can calculate the acceleration. Okay, the acceleration when calculated is the value 9600 divide 480, it will be equal 20 meter per second squared. Okay boys? Okay, this means the force acting equal mass times acceleration. The force equal mass of rocket equal 8 times 10 power 6 times acceleration equal 20, which equal 160 or 16 times 10 power 7. Also can be written in the form 1.6 times 10 power 8 meter per second. Newton. Okay, this is question number 5. After that, in the next page, question number 6. Two objects as shown in figure. The first of mass 6 kg and the second of mass 3 kg. The acting force acting on them is 18 Newton. So we want to find the tension force in the rope. This string or this wire acting on the mass 3 kg by tension force. To find the tension force, we multiplied by mass 3 kg multiplied by the common acceleration. Firstly, we must find the common acceleration acting on the two masses. Okay? To find the common acceleration equal total force acting on the two masses over total mass, which equal 18 Newton over 3 kg plus 6 kg equal 9 kg. 18 divided 9 equal 2 meter per second squared. Okay, this is the common acceleration. To find the tension force acting in the rope, so we multiply the mass, which equals 3 kg, multiplied by the common acceleration. 3 times 2 equal 6 Newton, which is number number D. Number 7, a man of 50 kg rides a bicycle on a road of radius equal 50 meter with speed 2 meter per second. If the centripetal force acting on man and the bicycle is 10 Newton, so the mass of the bicycle is, okay, we have the force Fc equal 10 Newton and speed equal 2 meter per second. The radius equal 50 meter. We want to get the value of mass of bicycle. Okay, I know the mass of man is 50 kg, but the total mass of man and bicycle is unknown. Since the force equal mv squared over r, we want to get the total mass by cross multiplication. We can find the mass equal F times R over V squared, which equal force equal 10 Newton, radius equal 50 meter, speed equal 2 power 2. So we can get the value of the mass, which will be equal 125 kg. This is total mass of bicycle and man. Since the mass of man equal 50 kg, so the mass of bicycle equal 125 minus 50, which equal 75 kilogram. This is the mass of bicycle only. Okay. After that, problem number 8. Number 8. If an aircraft executes a horizontal loop of radius 1 kilometer. Okay, firstly, radius 1 kilometer, which equal 1 times 10 power 3, as we say before, equal 1000 meter. That's the radius. Speed equal 900 km per hour. Speed, velocity equal 900 km per hour. To convert it into meter per second, we must multiply it by 5 over 18. So the speed equal 900 multiplied by 5 over 18, which equal 250 meter per second. This is the value of velocity. Okay? So the ratio between the centripetal acceleration and acceleration due to gravity, and use acceleration due to gravity equal 10. Okay? The centripetal acceleration equal v squared over r. V equal to 150 squared over r equal 1000. So the centripetal acceleration will be equal 62.5 meter per second squared. So the ratio between centripetal acceleration and the acceleration due to gravity equals 62.5 over 10. Its result equals 6.25. Okay, this ratio has no unit. Number 9. Object of mass 0.4 kilogram makes quarter revolutions in 0.1 second. Quarter revolutions in 0.1 seconds, so you can get from this information the value of periodic time. Okay, periodic time equal total time over number of cycles. Total time equal 0.1 second. Number of cycles, quarter revolutions. Okay, it will be equal 0.4 second. This is the periodic time. Okay, if its displacement equal 2 root 2 over 5 meter. Okay, displacement after quarter revolution. Displacement after quarter revolution. If you forget what's the relation between displacement and radius, you can draw again the kind of motion. Okay? If the body starts from point X and makes a quarter revolution, so it's end of motion at point Y. This is a quarter revolution. The displacement is the chord from the chord XY. This is the displacement, okay? And from O to X radius, from O to Y radius. From Pythagoras, r power 2 plus r power 2 equal xy power 2. That means 2r power 2 equal power 2 of displacement. The displacement in our given equal 2 root 2 over 5 power 2. Okay, so we can find the value of the radius, okay, by using your calculator. 2 root 2 over 5 all power 2, and we make divide 2 and taking the square root for the answer. So the radius will be equal 0.4 meter. This is the value of radius. We want to find the value of the acting force. Okay. To find the value of the acting force, firstly, you must get the value of the linear tangential velocity, which can calculate it from the relation equal to pi r over t. 2 multiplied by times the radius equals 0.4 over periodic time 0.4. So the linear tangential velocity, its value will be equal to pi. Okay? To find the centripetal force, which equal mv squared over r. So the centripetal force equal m mass of body 0.4, v power 2, velocity equal 2 pi power 2 over r 0.4. That means the value of force will be equal 4 pi squared. 4 pi squared. So the correct answer is number C. The last one. If the weight of a body on the Earth's surface equal 600 Newton, the weight of the body on the Earth's surface equal 600 Newton, then its mass on Moon's surface is. It is an easy problem. The weight on the surface of Earth, the weight which is denoted by Fg small or W equal 600 Newton. Okay? From weight and from the value of gravity of Earth, we can calculate the mass of the body. The mass of body equal weight over value of gravity of Earth, which equals 600 Newton divided 10. So the mass equal 60 kilogram. But you know that the mass is a scalar quantity. The mass of body is constant anywhere. Okay? So the mass of the body on the Moon's surface also equal 60 kilogram. So the correct answer is number C. This is the end of our sheet. This is the first sheet which have problems on weight, linear momentum, centripetal force, centripetal acceleration. Okay?